Hi, I am Somikda and I will be solving question number 1 of homework 11. Okay, so what do we have in question number 1? We have been given xt, which is a real WSS process with autocorrelation Rxxt, Rxx tau, and the power spectral density as omega. So what we need to prove? We need to prove that the autocorrelation Rx tau is real and even, and the power spectral density is even and non-negative. This should be very important. Okay, so now we come to the proof. Okay, now since xt is real, why we are saying it is real? Because we have been given it is a real WSS process. So we have x of minus t is equals to x star t, where star denotes complex conjugate. Taking correlation both sides, Rx tau conjugate is equals to expectation x t x conjugate t minus tau, which is equals to x conjugate t minus tau x t, since x t is real, which is equals to Rxx minus tau. So we have Rxx tau equals to Rxx minus tau, which implies that the autocorrelation of x is real. Now Rx minus tau is equals to x t minus tau t plus tau. Okay, let t prime equals to t plus tau, so Rx minus tau is expectation x tau x t minus 2 tau. Taking complex conjugate using the fact that the x function xt is real, we have t prime plus 2 tau x t prime by after taking conjugate, which is equals to Rxx tau, Rx equals to conjugate of Rx minus tau, which is equals to. So this gives us that Rx tau is both real and even. Okay. Now coming to the power spectral density. So the power spectral density can be defined as the integral from over the whole space, or from minus infinity to plus infinity, the autocorrelation function, that is Rxx tau e to the power minus j omega tau d tau. It's okay. Now since Rx tau is real and even, how can we say that? We can say that from part 1, which we have already proved. We have these power spectral density as can be written as xx omega from minus infinity equals to minus infinity to plus infinity Rx tau minus j omega tau d tau, which is equals to minus infinity to infinity Rx minus tau e to the power j omega tau d tau, which is equals to x spectral density of minus omega. So x omega equals to s minus omega, which implies that the power spectral density as xx omega is even. Furthermore, since Rx tau is greater than equals to 0 for all tau we have, the integral will be always greater than equals to 0 of this. How? Because Rx tau is always greater than equals to 0. E to the power minus j omega tau is always greater than equals to 0. So integral over the whole space of a function which is always greater than 0 will always be greater than equal to 0. So therefore xs omega is non-negative. So the power spectral density Sxx omega is both even and non-negative. Thank you.